Hey guys, welcome back to the tutorial series Introduction to Kubernetes. Today we are going to cover one of the advanced topic, DaemonSet in Kubernetes. Little bit about me. I am a JainishShah software developer. I love to play around new technologies and I love to play with container orchestration tools like Kubernetes. These are the links which you can use to follow me on GitHub, Twitter, and LinkedIn. Let's get started. So what is daemon set? The, similar to deployment or stateful set, daemon set also manages group of pods. But a daemon set is a different in a way that it only follows one pod per node model, which means you can deploy only one daemon set pod in Kubernetes node. So let's say if you have three node cluster, you can only deploy three pod of daemon set, right? Now, the way daemon set work, if you add a new node to cluster, daemon set will deploy the pod automatically to that new node. If you delete the node, the pod will be removed from that node during the next garbage collection run. Then obviously deleting a daemon set will clean up all the pod from all the nodes of Kubernetes cluster. Now, so when to use daemon set? So these are some of the use case. First is cluster storage daemon set. So for example, if you are deploying a cluster of cluster FS or Ceph inside your Kubernetes cluster, then you want to run a cluster FS client or pod in each of your nodes so that your node connect to local provider of cluster FS. So that way, running one pod of this applications per node makes more sense. That's where you can use cluster storage daemon set. Log collection daemon set. So some of example are like FluentD or FileBit. So this are log collector. What they do is they read log of your Kubernetes nodes, specifically of Docker daemon, and they push it to different applications like Elasticsearch or whatever your log monitoring mechanism is. Then then other type is node monitoring daemon. So there are some applications like AppDynamics or Sumo Logic, Sysdig, Datadog, New Relic, Prometheus, which you can use to get all the logs of Kubernetes node, everything including Docker, pod log, how the node memory is doing everything, and you can pass it to this applications or this services which can monitor and which can give you more capability to monitor your Kubernetes nodes. So these are some example of daemon set. Today we are going to do a advanced hands-on. We are going to use EFK stack, which is Elasticsearch, FluentD, and Kibana. So Elasticsearch we will deploy on Kubernetes, and then we will deploy Kibana, which basically provides a UI on top of indexes in data in Elasticsearch. And then we will deploy a daemon set with a FluentD, which collects or which reads the log of containers and pushes it to Elasticsearch. So let's get started. I have uploaded the code in my Git code repository Kubernetes, my introduction to Kubernetes inside the folder daemon set. So first we will deploy Elasticsearch. We are using deployment type. What we are doing is we are deploying Elasticsearch version 6.6.1. Obviously, we will create the service as well, which will be only accessible inside the Kubernetes cluster. As we are using Minikube, it will be only accessible inside the Minikube. Then we will deploy Kibana, and we will allow it to use node port so that we can access the UI of Kibana. And we have specified Kibana to talk to Elasticsearch running inside the same Minikube cluster. And if you see one thing here, we are deploying everything in a namespace called kubesystem. Because kubesystem is a namespace which Kubernetes uses to deploy the privileged applications. And then eventually we will deploy a daemon set. Uh, so daemon set is a kind in Kubernetes like deployment or stateful set. we are deploying DaemonSet. We are saying that it can run on the master as well because we are using Minikube, which is a single node Kubernetes cluster. And here in Fluentd by environment variable, we are telling it to talk to Elasticsearch. Now we are using name Elasticsearch because we created the service with name Elasticsearch, and port will be 9200. Obviously, scheme we are using HTTP because it's not secure in this case. If you are using secure, you might want to use HTTPS, and other way like specifying the resource, volume, mount, etc., etc. So let's get started. First, I will deploy Elasticsearch. It will create deployment and service. Then I will deploy Kibana. Right right now we are in namespace default, so we will not see anything which we created here. We will need to change the namespace. So I will do that running this command. What I'm saying is, in my current context, I want to change the namespace to kube system. Now, if we'll do kubectl get pod, we will see all the pod running inside the namespace called kube system, and we can see that Elasticsearch pod is getting started. Same way, the Kibana pod is getting started. We got some error in the Elasticsearch pod. Let's see what's it doing. Let's see the log. Okay, looks like it does not have permission to create directory. So what we will do, we'll SSH into Minikube. We will go to the directory which we are using as a host path for Elasticsearch, which is mount data. Okay, and we will give it at least permission to create directories inside this path. Now let's get out of this Minikube and let's do get pod, and we can see the Elasticsearch is now running. Just to make sure, let's tail the log. Great, Elasticsearch is running now. Now let's get the IP to access Kibana, and the command I have added it in the GitHub repository. So you are getting the pod, then IP of Minikube, and then you are combining both together. Let's try to access Kibana using this URL. Great, and you can see we can access the Kibana now. We will explore our own data. But right now, if you see in Discover, we don't have any index created because right now the Elasticsearch is empty. Nobody's pushing data to that. Now let's go ahead and create the DaemonSet. Now, to allow this DaemonSet to access running pod and data of each pod to read the logs, we had to create service account, role binding, and cluster role. We will cover that in one of the next videos. You can also learn that by going to Kubernetes documentation. The role is nothing but a permission that we are allowing this pod to access some of the data of the Kubernetes cluster. Now let's see if the DaemonSet is created, and we can see the DaemonSet Fluentd is created. DaemonSet will eventually create a pod as well. So the pod is also created. Let's see log of this pod. And we can see it is running and it has started adding the data to Elasticsearch as we have specified. So now if we go and refresh our Kibana, we will see that it has identified the index. We can pass that index as a pattern, and using the timestamp we can create index pattern. So it will basically read data offered on day-to-day basis. Everything that is uploaded to Elasticsearch by Fluentd. Now, if we go to discover, we will see, bunch of different logs. Now, if we see container image, let's see how many pods we have running. So we will just say print the pod ID, and these are the ID of all the pod running inside the Kubernetes cluster. So we, as of now, I think we have what, total 12, 13 pods running inside the container. But yeah, figure it out, try Kibana, try running Kibana yourself, and you will be able to see or create a dashboard like this for all the monitoring of your Kubernetes cluster. In this case is Minikube. So that's it for this video. Try it yourself, create different dashboard, see how you can monitor uh, how many pods are running inside the container, how many pods are healthy, how many container inside the pod, how many namespaces you have. You can do all these different things using the Kibana dashboard. So that's it for this video. You can say that we have learned deploying EFK Elasticsearch, Fluentd, and Kibana stack on Minikube. So if you have any question, feel free to add your question in the comment. If you have learned something new, give it a thumbs up. Don't forget to subscribe to my channel to learn more about Kubernetes. Thank you.